All right, so this website that I have open right now is Desmos.com. And if we go to Desmos.com and we click on graphing calculator, you're going to go to exactly that. It's a graphing calculator. Now, what I want to show us on here is what happens visually when you're solving equations. So one equation that you might solve in class now is something like sine theta equals 1/2. So do girls know when does sine theta, but you can't use theta, we have to use x. That's sine x. Where on the unit circle between 0 and 2 pi does sine of x or theta equal 1/2?
Pi over 6 and negative.
And pi over 6 and where else?
Pi over 6, 5 pi over 6.
Yeah. So if I was just, so what I did, if you look here, I just graphed sine and I graphed 1/2. And I want to know when are they equal? That's what you're doing when you're solving an equation, right? You want to know when is sine x equal to 1/2. And you girls just told me the answer from your head using the unit circle, pi over 6. Do you see it right here? It says pi over 6. And if I click there, 5 pi over 6. So I'm just going to hit projector mode, and that's just going to make this a little bit more bold. And you see right there, pi over 6 and 5 pi over 6. That's where my red and blue graphs are equal, but the circle, we could go around and around and around and around. So the directions on the problem only want, I'm going to draw 2 vertical lines. Vertical lines are x equals. So x equals 0. That's 0. And I also want x equals 2. And I'm going to do 2 pi. So you spell pi, and that's pi. I only wanted the answers between, oh, I should zoom in. Oh, the other way. I only want answers between the green line and the purple line. That's 0, and that's 2 pi over here. 0 and 2 pi. The blue line is 1/2, and the red graph is sine. Where is the blue going to be equal with the red? In between, that's there and there, right? So can you see how the picture will also tell you the answers, okay? If I said, when does sine of theta equal negative square root of 3, so we type SQRT, square root of 3 over 2. Now on the unit circle, where does the sine in the circle, if you picture that in your head, where does that equal square root of 3 over 2? Negative square root of 3 over 2.
5 pi over 3.
Yep, and
4 pi over 3.
Exactly. And if I click on it here again, you see we get the same answers. If I click and see where does my red sine x over here, where does that overlap or equal negative square root 3 over 2? And they equal each other here and here. And we could do that using the unit circle, but it gets interesting. Okay, so if I click here on the color, I make it invisible, invisible, invisible. All right, now here I'm going to look for a second. If I put A in front, I put B over here, parentheses, X minus, I don't know if I should do minus, I guess I'll do plus H, close, and then plus K. All right. Each of these does something to my equation, all right? And I have to put, actually with trig, they're very weird. I need parentheses around that to show it's together. And it says add slider. A slider is like something I can click and slide back and forth to change the numbers. So I'm gonna say, yeah, let's add sliders. A is 1, that's okay. B is 1, and I'm gonna make H 0 and K 0. So that means it's just y equals sine x. This is the same picture as before. Shh, tell us. Now, if I make A bigger, do you girls know what would happen to the graph if I make A a bigger number? I have to move my thing from my phone.
No.
So you know how on the parabola I just had on the paper, I drew the U-shaped graph?
Yes.
And then when I put a 2 in front, it made it more skinny. So when I do this, ready? I'm going to click on this blue dot. I'm going to make A bigger. Do you see what happens to the graph as I make A bigger and bigger?
Yes.
So that's called a vertical stretch. So now if I ask, when does 4 sine theta equal 1/2? It's not maybe going to be the same answer anymore. So if I go here, before when I had 1/2, it was pi over 6 and 5 pi over 6, right? But now it's not pi over 6, it's 0.125 and 3.016. So the answers are changed because when I stretch this bigger and bigger, it changes my answers. And if I bring it down, 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 back to 1, pi over 6 again, 5 pi over 6. Next thing that we could change is B value inside here. Oh, and if I make A smaller than 1, look what happens here. Do you see it gets squashed closer and closer and more flat? All right. What do you think will happen when A is negative? What do you think will happen if I make A become negative? Want to find out? Let's see. Ready? What happened? Now it's negative, positive.
Yes.
That's called a reflection. It reflected over the x-axis. Then I'm going to go back. Original is 1, okay? Original is positive 1 in front. That's just sine x then, because A that I have like here that I'm working with is this number in front of sine. So normally it's a 1, you know? Then B inside. Do you see like example 6 on that homework? I made the B theta, it was like 2 theta inside, right? You know which one I'm talking about? 2 cosine 2 theta minus 1?
Yeah.
That one?
Yeah.
So when you now change B, but number 6 was like 2 sine theta, so the 2 made it this way. B, when I make B bigger, watch closely what happens to B. It's very weird. If I make B bigger, do you see what happens to the graph?
Close.
It's called a horizontal compression, like you're squeezing it closer to the y-axis. But if I go back, original was 1 right there. And if I go to between less than 1 but positive, you see it stretches it away, pulls it further. So your answers will be different. See, if I make B 1/2 inside, now it equals 1/2 at pi over 3 because I stretched it out, okay? And if I make that negative, it flips it the other way. So very interesting, okay? Then, but we'll learn this later. That's why I'm saving it, this example. H is this over here, plus or minus. Do you remember what that does to your graph? You know, that's probably 2 years ago for you. What's it doing if I make H bigger? Do you see what it does to the whole picture?
Yeah.
What's it doing? Or make it smaller?
Like moving back and
yeah, like left and right.
Yeah, left and right.
Yeah, that's called you're translating it. You're like not translate English Spanish, but like translate like translation left, translation right. Like you move it left or move it right. So with H, when you make it minus, it actually goes to the right, and when you make it plus, it goes to the left. It's backwards. See here, I'm going negative, but it goes to the right. My graph, right? You see that? But when I go positive numbers, it moves to the left. So everything's backwards inside. B and H, they're backwards because when I make B bigger, it makes it smaller. When I make b smaller, it makes it bigger. You know, a little crazy there. So I'll go back to 0 because that's the original. K on the outside, watch what happens. It moves it up and down. So if I moved it up this much and I ask you, when does this graph equal 1/2? You have no answer, no solution, because they don't cross ever. Because the sine graph will keep going forever and never touch the blue one. So those examples that are numbers 5 and 6 on the worksheet, on that paper, don't worry yet. I wanted you guys to like look at it, maybe try it. I don't want you to fully solve it yet because we need to do it together in class so we can kind of go over some of this stuff together. But last year, the kids in the class learned Algebra 2 last year. You girls did geometry at your school last year. So it might not be like graphing, might not be that fresh for you. So hopefully this will help you understand like left, right, up, down, what everything does. And when we do it in class, like if you know this, it'll help you understand the answers better. Okay?
Okay.
So don't worry about doing those examples yet. See, look at these. You click it, it's lovely. I think I'm gonna make a teacher lesson of this and I'll share it with you guys where you guys click on it as students and you girls can like slide it around and play with it and see what happens to different graphs. Okay? But don't worry about 5 and 6 yet because we don't need to fully solve them at this time. If I show you, let me see. What was, see how this one, you solved it already for me, right? Because if you add 1 and divide by 2, we get this. And you girls told me theta equals pi over 6. And you told me 5 pi over 6, right?
Yes.
But if I change it to sine theta minus 3 pi over 4, minus 1 is 0. Add 1, divide by 2, but now instead of sine theta, I have sine big thing, my equals 1/2. Then you would get, instead of theta equals pi over 6 and 5 pi over 6, you get theta minus 3 pi over 4, because that's what's inside now, equals pi over 6 and 5 pi over 6, okay? Because it's still, when does sine equal this? That to finish, okay, you would add 3 pi over 4 to those answers. What's pi over 6 plus 3 pi over 4? And then what's 5 pi over 6 plus 3 pi over 4? So that will give you, that's the extra step now. So you take whatever's in here, theta minus 3 pi over 4. So instead of it theta equals, it's theta minus 3 pi over 4 this time. So here was theta. Okay. And in the next one, it's this inside instead. So do you see it's like the same thing, but with an extra part down here? And then how do you add those? That was like what example 4. I asked you girls to add stuff together. You had to find a common denominator, right?
Mm-hmm.
So do you see if you multiply by 2, multiply by 3, that's 2 pi over 12. Sorry, it's squashed down here. Okay. Plus 9 pi over 12. And that equals 11 pi over 12. So that's one answer. That's the decimal that the Desmos gave us. I'll show you in a second. And then, sorry, this is in my way now because I drew him before. Add that, multiply by 2, multiply by 2. Multiply by 3, multiply by 3. 10 pi plus 9 pi over 12 is 19 pi over 12. So these are my answers. This and this go with that equation, but this and this go with that equation. Now, if I look at the graph I show you again over here to compare it, okay? If I put in the equation, y equals 2 sine theta. So I'm going to make A over here. I'll type 2. Theta minus 3 pi over 4. So B is still 1. H is minus 3 pi over 4. K, what's K for this one?
1 minus 1.
Yeah, minus 1. And then the other side would be 0 originally. When does it equal 0? The answers are here and here. Beautiful. That's what we got. 11 pi over 12 and 19 pi over 12. Oh, maybe you can't see it. Can you see it? Hold on. Oops. Sorry, I have to move that up to, there you go. So you could see I clicked on it. That graph, then I changed all my letters on the side to what matches the example. And I clicked on when they equal each other because I want to make sure also that I'm only graphing and finding answers between x equals 0, right? And 2 pi. So those are the two lines I got to find my answers between, and there they are. But if I move it back and I shift h, instead of going to this moved it to the right 3 pi over 4. If I put it back to 0 and I put k still negative 1, everything else is the same. Well, now when does it equal that? At 5 pi over 6 and pi over 6. But when my h moved to the right until I hit whatever it was, negative 3 pi over 4, it moved and moved until my answers were two different answers. So I want to spend time going over that with everybody in class. So that's why I don't stress out about it. But, you know, you girls obviously came from a whole other country and you did your math in a different order before. So you could get a little preview. But I'll save this video and I'll put it on the computer. But you can even go to this website and do the same thing. So you graph y equals 2. This is just 2 cosine theta minus 1. And then graph y equals 0. And then you find out, where do these graphs intersect? You should get the same answer you would get if you solve this. So if I add 1, divide by 2, when does cosine theta, where does cosine theta equal 1/2? That's on the x value, positive 1/2. So to the right a little bit. So it's going to be the angles over 3. Do you know what they are? It's pi over 3 and 5 pi over 3.
Yeah,
Okay. It's okay. So it would be these two, I promise. Okay. But if you go then in Desmos.com, graphing calculator, graph this, and you could even graph x equals 0 and x equals 2 pi. Okay. But you can't use theta. You have to use x.
Yes.
And you can't use just pi that way. You would write pi for pi. And if you need the square root symbol, if you need this symbol, you write SQRT, and that'll make it come up. But then if you graph, I'll just move this last thing out of the way. So the one I really gave was 2 cosine parentheses 2x you would put in, minus 1 is 0. It's going to take your graph and it's going to stretch it out wider. Instead of being like this, it's going to be more like this. And then you just find, where does it cross 0? Where do they cross? And those should be your answers, something different. Or you do it kind of like this. So it would be a theta if you solve by hand. I like to use theta. Instead of writing in this step theta minus 3 pi over 4 or just theta, you're just going to write on your paper 2 theta, wherever you wrote that. Okay? And then you could probably solve it from there. But don't go crazy. We'll talk about this more in class. Okay. And like I said, I'll put this into a little video and I'll send it to you girls. Okay.
Okay.
All right. I can stop this recording.